Před námi je teď prezentace Fakulty rybářství a ochrany vod Jihočeské univerzity. Unikátní projekt Recyklace živin ze zemědělsko-průmyslových zbytků cestou kultivace mikrořas jako krmiva pro ryby představí hlavní řešitel, španělský biolog Yanes Roca.
Good night, welcome to University of South Bohemia. That's where we're located now. We will talk about the algae for fish. This is a European Union project, Interreg, Austria, Czech Republic. There are 4 partners involved in this project. It's University of South Bohemia, which is FROV, that's where I belong. Algatech, which are located in Trebon, and they are in charge of the algae bioreactor development. We also have BEST, which are located in Austria, in Toul, and part of the University of Vienna. And the government, the Bundesamt für Wasserwissenschaft. So these are the 4 partners. We work in parallel, developing the different parts of the project itself. Roles are described here in the slide, so you can look at it quickly if you are interested. I hope you are. Going into the project itself, we call it Continuous Integrated Larval System, or SILS. The concept itself is very easy. It's a standard aquaculture protocol for hatcheries. We pretty much use algae production. This algae is going to be fed into the rotifer system, like you can see here, and back into the fish tank where the larvae are located and be fed through the system. So we're using a very standard system. But the idea is to do a continuous feeding, direct continuous feeding. So this process will take over 24/7, and fish larvae will be fed with non-stop in order to meet their requirements. So there's a first step, which is working on the rotifer feeding using the algae bioreactor that is developed by Algatech in Trebon. This pretty much we produce algae, fed it into the rotifers, and using software and a peristaltic pump, we will be able to meet the needs that rotifer production needs in order to grow fast. Once we have produced or get the number of rotifers that we would like to have, we will proceed to collect these rotifers in a mechanical way using software, which we will save a lot of time on the labor side of things. Here you can actually see a small sketch of the diagram, how we're going to do this, and if you're interested you can look at the slide in more details later on. We only have 8 minutes, so we have to be very fast, I've been told. The third step, which is pretty much from the rotifers into the fish larval tank. This is going to be done, as I mentioned before, through the mechanical draining, and pretty much we'll use a peristaltic pump and software to feed the larva. The key component of all this project itself is synchronizing, so using software in order to synchronize all the different systems. Something that is already been done and it's working already as we speak. It's algae bioreactor, is located in Trebon, and this is the bioreactor itself. The second stage, which is the green part or the green technology of this project itself, is to reuse the wastewater produced by rotifers and fish. This wastewater is very high in ammonia, in nitrates, which is toxic for both rotifers and fish. And instead of getting rid of it and dumping it into whatever normally aquaculture does, which is either clean it or send it to riverbeds, we will be reusing this to feed the algae, which the algae likes to have this type of nutrients like ammonia and nitrates. So the main problems that we come across is the software, as I mentioned, the mechanical filtration and collection of rotifers, rinsing those rotifers, and also eliminate any pathogens that are in the culture, so they don't go into the fish culture itself. The idea of this project is to test the technology So we're developing collaborations with the 4 partners, as I mentioned. The idea is also to improve the technology for the larval culture. In our case, it's going to be pike perch as the model fish that we're going to be using. And also looking at alternative algae for aquaculture with different nutritional values. And last but not last is knowledge transfer, that we're going to be obviously offering our results, our testing the technology to any companies who's interested in using such technology, and hopefully make some profit and use some green technology that will help the environment overall. The idea of this technology can be applied globally to marine species that meet this type of characteristics, which tend to be a small mouth, nutritional deficiencies on the larvae, and also behavioral aspects to it. As I mentioned, the idea is to reuse all this wastewater and recirculate the ammonia and nitrates and feed it back into the algae. So yeah, well, thank you very much for watching our presentation. Sorry, I have to be very fast because I don't want you guys to fall asleep. If you have any questions, please contact us. I will be happy to answer any questions or queries that you have. Thank you.